Okay, so before we can talk about performing double integration over general regions, we have to talk about how it differs from what we looked at in the previous section. So in the first section, we looked at rectangular areas only. But what if we wanted to evaluate a double integral over any region? So, for instance, in this diagram, we have the idea that we have a surface. Okay, so let's define this surface as S. And over the surface S, let's say for some reason we want to bind it by some other function. Let's call that function or that region D, right? So our goal is to not just be able to evaluate the volume bound on a rectangular region, but in any sort of curvature region. Now, before we can do that, no matter what the regions are defined by X and Y, we have to determine these things called type 1 and type 2 regions. Type 1 are the type where if you graph the area in the XY plane, if you can draw and it basically passes the vertical line test between the two functions or the two bounds, that means that it's a type 1 region. All right? So just basically, after you graph your region, if you can draw lines and one function touches the other function up and down without it intersecting again, it's a type 1 region. Type 2 region, if you can draw from left to right without one function touching another function, then that would mean that it's indeed a type 2 region. I want you to notice that in the two diagrams, the first one is not a type 2 region because if I were to draw a vertical line, notice that it would intersect in multiple places. The same thing with the type 2 region. This is not a type 1 region because if I were to draw a vertical line, okay, notice that the function would intersect itself. So our goal when we're doing this is to first graph the region that's being given. Okay, so first we're going to graph in the XY plane. Right? Once we graph in the XY plane, we're going to set up the double integral. And then finally, we are going to evaluate the double integral. Below, these are the definitions for type 1 and type 2. And of course, we're going to assume, just like with any integral, we're going to assume continuity. Okay, and we have this region D. All right, so if it's a type 1 region, we're probably going to evaluate with respect to X first, because the function most likely will be in terms of X. And then if for some reason, I think this is backwards, all right, so that should be dy dx, just because in general, if we're looking at the function in terms of y first, all right, so I do apologize. So I'm going to go back just so you guys can see this and let you know. I got to turn this draw off. All right, we can, well anyway, just reverse those and it should be okay with everything. Alright, so in the next sections what we're going to do is we're just going to evaluate some double integrals so we can see the examples of how this is done. Okay, but overall, hopefully this helps you to understand the difference between what was done initially with only rectangular regions and now we're going to be able to evaluate over any general region.